Good morning all. In this video, let us discuss about Gauss law, integral and differential forms. So in that, first let us discuss about integral form of Gauss law. So the statement of Gauss law is the normal electric flux over a closed surface is 1 by epsilon naught times the total charge enclosed within the surface. Now what he is saying, the normal electric flux pi E is 1 by epsilon naught times the total charge enclosed within the surface. Right? Now this is the Gauss law in integral form. So the normal electric flux pi over a closed surface is equal to 1 by epsilon naught times the total charge enclosed within the surface. If you remember statement, you can write mathematical part. If you remember mathematical part, you can write a statement easily. So now we have to prove it. Now let us go for the proof. Alright. So now for that, I am considering a closed surface of arbitrary shape. Okay. Now let O be the center of surface. O be the center of surface. Okay. Now let us place plus Q charge at the center of surface. Let us place plus Q charge at the center of surface. Now, within this closed surface, consider a point P. Within this closed surface, consider a point P. Now, this point P is at a distance r from center of surface. This point P is at a distance r from center of a surface. Right? Now, first, what is electric field direction? We placed this closed surface in an electric field, uniform electric field. So now, in my last video, we discussed that for positive charges, electric lines of flow will be outwards. For negative charges, electric lines of force will be inwards. Now here, we considered positive charge. So for positive charge, electric flux of lines will be outwards. So electric field direction is outwards. Right? Electric field direction is outwards. Now, let us consider a small elemental area around this point P. We considered a small elemental area around this point P. Right? So now, this area is denoted by vector ds. Okay? The magnitude of that vector is area of this surface itself. The magnitude is the area of this surface itself. Now the direction, now if this is the outward normal drawn from this elemental area, then the direction of vector ds will be along this outward normal drawn. The direction of vector ds will be along the outward normal drawn. Right? So now, let us write the flux, the electric flux through this electric flux through elemental area. We will write it as d pi e is equal to, what is the electric flux formula? integral E dot ds. And if theta is the angle, E ds cos theta, right? That is nothing but electric flux is the product of horizontal component of this electric field and area of the surface we considered, right? So now I'm writing this, that is E dot ds, that is E ds cos theta, right? Now in my last video, we find it the value of electric field intensity at a point, that is 1 by 4 pi epsilon naught q by capital Q by r square. Now let us substitute this here. Now what we will get? D pi E is equal to 1 by 4 pi epsilon naught q by r square ds cos theta. Now I'm writing in a systematic way the same, such as q by 4 pi epsilon naught ds cos theta by r square. Right? The same thing I wrote. Now what is this ds cos theta by r square? Now this elemental area, okay, this elemental area will subtend an angle at point O. So that angle we call it as solid angle. Okay, that area, elemental area, will subtend an angle at a point O. So that angle we call it as solid angle. So the angle subtended by this area at a point O, we call it as solid angle, d omega. And the value, the mathematical value of solid angle is area into cosine angle divided by distance square, ds cos theta by r square. Now substituting this solid angle in the above equation, we get d pi e is equal to q by 4 pi epsilon naught, q by 4 pi epsilon naught d omega. Now we got electric flux value due to this elemental area. Now we want electric flux due to entire surface, closed surface, entire closed surface of arbitrary shape. So we have to integrate. Pi e is equal to integration for closed surface q by 4 pi epsilon naught d omega, or we write it as q by 4 pi epsilon naught integral d omega. And the value of integral d omega is equal to 4 pi. Right? Now substituting the value, pi e is equal to q by 4 pi epsilon naught into 4 pi. So 4 pi cancels, and the integral form of Gauss law is q by epsilon naught. The integral form of Gauss law, that is the electric flux, the normal electric flux passing through any closed surface is equal to 1 by epsilon naught times the total charge enclosed within the surface. So this is the integral form of Gauss law. So if you want notes, pause the video and note down this. Now next, let us move for differential form of Gauss law. Now, differential form. Now differential form of Gauss law. Let us move for differential form of Gauss law. So now only we wrote that pi e is equal to the integral form. What is pi e? Integral e dot ds, no? This is nothing but 1 by epsilon naught times the total charge enclosed within the closed surface placed in an electric field. Right? So now, integral E dot ds is equal to Q by epsilon naught. I'm writing epsilon naught on this side. Integral E dot ds is equal to Q. Now, if we assume that the charge Q is distributed uniformly throughout the surface, okay, if Q is distributed uniformly over entire volume, then the charge Q is written as volume integral rho dV. If Q is distributed uniformly throughout the entire volume, then charge Q is written as volume integral rho dV, where rho we call it as density of charge or charge density. Density of charge. Now substitute this value to in equation 1. Epsilon naught integral E dot ds is equal to volume integral rho dV. Right? Volume integral rho dV. Now, this is surface integral. This is volume integral. Right? Now, let us convert this surface integral into volume integral. How we will convert? By using Gauss divergence theorem. So by using Gauss divergence theorem, let us convert this surface integral E dot ds into volume integral. What Gauss divergence theorem says? Integral E dot ds, the surface integral of any vector, is equal to the divergence of volume integral of that particular vector. So how we will write? Divergence of, here we are talking about electric field. So the divergence value of the electric field, the volume integral of divergence value of the electric field. Now let it be equation 3 and now put 4 in 3. Right? So epsilon naught in place of this integral E dot ds, volume integral del dot E dV is equal to volume integral rho dV. Alright. Now next, what we need in place of E dot ds, I substituted this volume integral using divergence theorem, Gauss divergence theorem. So epsilon naught del dot E is equal to rho, or del dot E is equal to rho by epsilon naught. This is one of the form. So in vacuum, the displacement current is written as product of permittivity and electric field. Right? The displacement current. So from here, E equal to d by epsilon naught. Substituting here, we get del dot d is equal to rho. So this is the integral and differential forms of Gauss law. If you like my video, like it, share it and subscribe it. Thank you for watching my video. Yours, Reshma Physics.